Okay, thank you. So in this lecture I am going to discuss Thevenin and Norton parameters for complicated circuits. So first I will briefly discuss what is Thevenin and Norton parameters, then we will solve few problems. Okay. So if you have one network, so this is one network, any terminal A and B, this network can be simplified to one simple Thevenin voltage and one resistance. So total network could be replaced by one voltage and one resistance, and this voltage is called Thevenin voltage and this resistance is called Thevenin resistance. Okay, and how to find the VTH and RTH? So VTH is same as the open circuit voltage. If you keep this part open, A and B open, then if you measure this open circuit voltage, that voltage is nothing but VTH. Okay, and to find RTH, you need to look back from this terminal. So then to find RTH, this is important. So same network but remove independent sources. Okay, means voltage source should be short circuited and current source should be open circuited in the network, and then you will get only resistances and dependent sources inside the network. Then if you measure the equivalent resistance looking from this side, so this equivalent resistance is nothing but RTH. Okay, so this is the formal way to find VTH and RTH. So VTH is open circuit voltage at the terminal and RTH is the equivalent resistance looking from the same terminal AB just after removing independent sources. So voltage source shorted and current source open circuit. Okay, so you should keep this thing, remember that you will be removing the independent sources but not dependent sources. Don't remove dependent sources. Okay, now so these two parameters VTH and RTH we can calculate separately. We have some other things what you can do. So if I connect, suppose one voltage source with this one, suppose if I connect a voltage V and if I assume that current is flowing I from this source, right? So you can get one equivalent equation. So what is the equation? So the potential drop across RTH is, this one is I into RTH. Is it okay? And this is VTH. So total voltage V will be equals to simply the potential across RTH is I into RTH plus VTH. So this kind of equation you will be getting. So whenever we have one network and there if I connect a source like this B and if I assume that current is entering to the network is capital I, then we will be getting a linear equation like this. Always it is true. Then you can compare this equation. The independent term will be VTH and coefficient of I is RTH. Like if you get V equals to 3I plus 5 after solving this network, adding one voltage source V, then VTH is your 5 volt and ITH, sorry, Rn or RTH is 3 ohm. Is it okay? So this is very simple thing. In briefly I am discussing this one because in this lecture we are going to discuss the problems, not the theory. Theory part I have discussed in detail in my lecture videos. So if you have any doubt, please go through that one. So here we are going to solve few problems. Okay, so let us start few problems to solve it. Okay, the first problem is this one. So can you find in this circuit, it is said that you can find the capital I. So this current you can find out. Okay, but first you can simplify the network about this A and B terminal. So first replace this terminal, this one, by one potential source and one resistance, that is the RTH and VTH, and then you will be connecting, this is your node A and B, then you will be connecting this resistance 15 ohm and you will find the current I. We are interested to find out all the three parameters VTH, RTH and then capital I. Okay. So what method you will be using? Somehow we need to find out VTH and RTH. So many ways we can solve this problem. So can you suggest anything? Anyone? Suppose I need to find out VTH. How to find VTH? So remember, we are considering this circuit only. Which circuit? This circuit. This is your 80 volt. Then 90 ohm is connected here. Okay. Then there is a current source. Then 90 ohm again connected here. Then it is 60. This is the node A, this is the node B, this is your 60 ohm, this one is 2 ampere. So can you find VTH? Anyone? And how to solve it? So I have said that VTH is nothing but VOC. So here if you find the VOC, open circuit voltage, that will be same as Thevenin voltage. Okay. We will keep everything in the network. We will try to find out the open circuit voltage VOC. Okay. So we have two sources. One is 80 volt source, other one is 2 ampere current source. Okay. You can use superposition principle to find VOC. I think that could be very easy comparatively to other things. You can also use okay. So this is 180 volt, right? Thank you very much. So it was 180 volt. Right. Yes, VTH is 90 volt, it looks correct. But how you have got these things? Which method you have used? It is open circuit voltage, you can find out. You can use source conversion to simplify the circuit, or you can use the other things like superposition principle. If I use superposition principle, so can you see this one? Suppose if 180 volt source is acting alone, 180 volt is acting alone, right? So what is the circuit? So current source, I will remove it. I will use that 180 volt source is acting alone, and second time I will consider that 2 ampere current source is acting alone. Then I will find out VOC1 and VOC2. Okay. Yes, superposition principle is applicable, as well as source conversion is also good. Okay. So this is your 180 volt, this is 90, this is 90 ohm, and you have this one is 60 ohm. So what is V1? The V1 I can find out. Similarly, when this is 2 ampere current source is acting alone, try to understand this one. That time this voltage source I will make it shorted. Earlier I have made current source open circuit here because I have considered 180 volt source here and current source should be made open. So this I have made open. Okay. So this is your 2 ampere current source. It is your 90 ohm. Right. This is your 90 ohm. And this is your 60 ohm. Okay. So this voltage is V2. Can you find V1 and V2 quickly? So what is V1 in this case? V1 is potential divider circuit. It is 60 upon total resistance 90 plus 90 plus 60, 180 plus 60, 240 into 180. Okay, so I think it is 4, and this one is 4 and 5, 45 volt. Is it okay? Am I correct? So I am not writing any equations, nothing. Just I am using the superposition principle. I am considering 180 volts source one at a time, and next time I will be considering 2 ampere current source one time. So can you let me know what is the current through this side? Anyone, can you please find out the current through this one? This I. Please let me know what is the current through this 60 ohm resistance when only 2 ampere current source is acting alone. Okay. So I is 0.75. Is so. So how will calculate? So this is a current divider, you can use it. So this is one branch, this is another branch. So total current is 2 ampere. That is divided by these two branches. This branch is 90 ohm resistance, and this branch is having 90 plus 60, 150. Okay. So if you use current divider, this side current branch will be the opposite resistance 90. It is 90 upon total, that is 90, plus this side branch is 150, that I have said 90 plus 60. multiplied by supply current, that is your 2 ampere. So it is 90 into 2 by 240. So this one, these things, and this is 3, this is 8, and this is 4. Yes, 3 by 4. It is a 3 by 4 ampere. Correct? This is 3 by 4 ampere. So what is V2? So you can find out the V2 easily. So what is V2? 60 into I. No? Because current is I. So the voltage across 60 ohm is 60 into I. So it will be 60 into 3 by 4. 15. So again it is 45 volt. So V1 is 45 volt, V2 is also 45 volt. So what is VOC? So this VOC will be simply, okay, I write here, VOC is same as V1 plus V2, that is 45 plus 45 is 90 volt. That's VTH is 90 volt, is correct. So Thevenin voltage is this one, 90 volt. Now let me calculate for the same problem. Let me calculate the RTH. So how to calculate RTH? So this is very simple, because it doesn't contain any dependent sources. So what you will do? So if it is not having any dependent sources, just remove the source, voltage source and current source. Voltage source short circuit, current source open circuit, and look from this terminal. So this is your 90 ohm, this is another 90 ohm, and this is the resistance. Fine. So this voltage source is short circuited, this current source is made open, and this is your 60 ohm. This is the terminal A, this is terminal B. Yes, VOC and VTH is same. So in a network, the open circuit voltage VOC and Thevenin voltage, that is the same thing. Okay. So now if you look from this side, the equivalent resistance you can find out. What is this? This 90 and 90, this is your 180 ohm, these are in series. Then 180 and 60, they are in parallel. So R equivalent is nothing but 180 and 60, these two are in parallel combination. Okay, I think it's simple. So 180 into 60 upon 180 plus 60 is 240. So this is 4, I think this is 45. So this is 45 ohm, exactly correct. So RTH is same as R equivalent, that is your 45 ohm. Okay, so you can see that this circuit about the node A and B, this voltage I have got 90 volt and this is your 45 ohm. And now if I connect this resistance 15 ohm, easily we can find out the current I. So what is the current I? Anyone can find the current I now? This is very simple. Total voltage is 90. by total resistance. So I this is a current through this loop only. Total is 45 plus 15 is 60. So 0 will cancel. The 3 by 2 means 1.5 ampere. Okay, is it clear? Good, very good. So current is 1.5 ampere, so I think this problem is solved. Now we will consider one complicated one, which will contain some dependent sources. So do you have any question? I hope you are following me. Okay. Now this is the next problem. Can you find VTH and RTH for this circuit with respect to the node A and B? This is plus and this one is minus. Okay. So how to calculate this one? The circuit is having one dependent source. So it is said that if the current through 3 ohm resistance is Ix, then this current source will provide 1.5 Ix. Okay. And this is 5 ohm, this is 6 volt, this is your 4 ohm connected. So how to simplify the circuit? So you may consider little bit here, or I think it is also fine if you can calculate these things from this one. Okay. So how to calculate? You can go for this one at this node. It will be simplified. Suppose if it is A prime and B prime. So can you first find out the Thevenin equivalent circuit for this network? Then I will connect the 4 ohm. I will go for A and B. It will be a little bit easier for you. Okay. So if we go for VTH, so I am considering A prime, B prime, this node. With respect to this node, I want to simplify the network. This is your A prime and B prime. Then I will connect this 4 ohm and I will get A and B. So that will be much easier. So I will call it, this is VTH1 and RTH1. Not exact one. Okay. And at the end, if we simplify this thing, again, I will be getting one resistance and one voltage. That will be your VTH and RTH. Are you following me? What I am doing? I am considering one sub network, that is A prime and B prime node. With respect to this one, I want to calculate Thevenin voltage and Thevenin resistance, and then I replace that thing in the network. I will add 4 ohm. Again I recalculate the Thevenin and Thevenin voltage and Thevenin resistance. for this node A and B. Okay. So can you find VTH1? So what is circuit? Circuit is this thing, 5 ohm. This is one dependent source. Be careful here. This is your 3 ohm. This node is A prime and B prime. This source is 6 volt. Is it okay? If this current is Ix, this current is 1.5 Ix. Now I have kept it open because I need to find out Thevenin voltage. So I need to find out open circuit voltage VOC. So here this open circuit voltage VOC is nothing but the VTH1. So anyone can find out VOC. So under this open circuit condition, anyone can find out what is the Ix? Please let me know what is Ix. Yes, VTH1 looks 6 volt. So what is Ix? If it is open circuit, obviously Ix is 0 ampere. Because no current can flow in open circuit condition. Correct. If Ix is 0, this current is also 0. This is also 0. 1.5 times Ix, it is 0. 0 means open circuit. So there is no potential drop across this one, it is disconnected. I can say it is disconnected. So there is no drop across 3 ohm, no drop across 5 ohm. Just this 6 volt source will be available at the output end. So VOC will be simply the 6 volt. If no current is flowing in the circuit, there is no drop anywhere. So open circuit voltage will be same as 6 volt. Is it okay, everybody? Okay. Now let me find out RTH1. Okay. To find RTH1, what I can do? So here I will find out RTH1. So what I will do? So this 5 ohm resistance I will consider. This 3 ohm also I will consider. The dependent source should be there, that I can't remove. If this is Ix, this is 1.5 Ix. Okay. But this side, this independent source, I can make it sorted. I will make it sorted. Okay. Now we are going to find out RTH1. What is the Thevenin resistance? Okay. So can you find RTH1? So what I will do? To find RTH1 between this node, that is your A prime and B prime, this is the target now. Now I want to connect a source V, and I assume that current is I. So this V upon I will give you the resistance, because resistance is nothing but voltage upon current. So can you find out total current I supplied by the source V and V upon I? Is it okay? So how to solve it? Now you can see that this current is 1.5 amp Ix times Ix. This current is Ix. So if I take KCL at this node, out of this 1.5 Ix is going to this side. So obviously this side current is 0.5 Ix. Okay, because total current is 1.5 Ix is coming, that is provided by dependent source. Are you convinced? This is very important to understand. So this total voltage is V. Now here you can see that this current is given that it is capital I, this side is Ix, but in one circuit only, so this one current is flowing. The convention is, I have considered it is Ix, it is I, it's opposite way. So obviously this capital I is opposite of Ix. Is it okay? So what is the voltage drop across this 3 ohm resistance? So if I consider I is flowing, 3 into I, this is plus, this is minus, and potential drop across 5 ohm resistance, this is plus, this is minus, 0.5 Ix times 5, right? So total supply voltage is V. So now if I take KVL, Kirchhoff's voltage law, so supply voltage is V minus the drop across the 3 ohm resistance is 3 times I, okay, because this is plus, this is minus, again this is plus, this is minus, minus times 0.5 Ix times 5 is the resistance, and that is equals to 0. I am considering this loop, bigger loop. This is a voltage source, this is a resistance, this is a resistance, and this is a loop. This bigger loop is sometimes called as super mesh. So actually I am considering super mesh concept. I will ignore this side, this one. I will not consider the voltage across this dependent source, this voltage source, this resistance, this loop. There I will apply KVL, Kirchhoff's voltage law. This is the voltage, supply voltage V minus drop across 3 ohm, 3 into I, and again drop across 5 ohm, 0.5 Ix is the current and 5 is the resistance. So 0.5 Ix into 5. Okay, so if I replace Ix by minus I, then what is happening? V minus it is 3I, and this is your 2.5 is a plus. Ix I am replacing by I plus 2.5, okay? I, that is equals to 0. Is it okay? So what is this? V equals to 0.5I. So what is V by I? So V by I am writing here is nothing but 0.5. So RTH1 is only 0.5 ohm. Have you got these things? So now you can see that you can come to this one. So this RTH1 is 0.5 ohm. This VTH1 we have got 6 volt. Now can you find out exact VTH and RTH? Can you find out VTH and RTH? So it is very simple circuit. One voltage source, one resistance and one resistance here. So it's a potential divider circuit. So VTH will be potential division across the 4 ohm. So it is 4 upon total. 4 plus 0.5 is 4.5 multiplied by 6 volt. Am I correct? Are you following me? So first we have computed the Thevenin equivalent with respect to these two nodes, A prime and B prime. Then now I am connecting this 4 ohm resistance. So this was the Thevenin parameters VTH1 and RTH1. VTH1 we have got is 6 volt. RTH1 we have got 0.5 ohm. Now I have connected 4 ohm. Again I want to replace this network by simple one Thevenin parameter VTH and RTH. Okay, so this will be so simple. So 3 1.5. Okay, so you are getting 16 by 3 means 5.33 volt. I think it's correct. Okay, and what about RTH? And what is RTH? No, RTH1 is 0.5 volt. Sorry, 0.5 ohm. Be careful. So RTH1 is 0.5 ohm. So you need to calculate the RTH looking from this terminal. That is actual RTH. So if you make it sorted, this end sorted, then RTH1 and 4, these two will be in parallelly connected. So RTH will be actually 4 parallel with 0.5. Okay, am I correct? And that value will be very close to 0.5 of course. But what is the exact value? So this is simply RTH1 you can compute 4 into 0.5 upon 4.5. Okay, so it is basically, this is 9, so 4 upon 9, and 4 upon 9 is 0.444 kind of things. Yeah, exactly correct. Perfect. So RTH we have got it 0.444 ohm, and VTH we have got it 5.333 volt. Okay, is it fine to all of you? I hope it's clear. Now can you find these things? Now this is a circuit. Can you find VTH and RTH for this circuit with respect to the node A and B? Can you find? Now can you let me know what is the VTH for this circuit? Anyone please? Can you tell me what is VTH? Without computing anything, you can answer this thing, the VTH value. Anyone? Can you tell me what is the VTH? Just looking at the circuit. Yes, it's absolutely 0. Correct. So this is equal to 0. Why? Because the circuit is not having any independent sources. If there is no independent source, current source or voltage source, so you can't expect any voltage across the terminal A and B open circuit voltage. Okay, so circuit is not having any independent source, thus VTH will be perfectly 0. Without calculating anything, we can say that it is 0. Right? Good. Now, how to calculate RTH? Now, to calculate RTH, we will consider this circuit. So, this is plus, this is minus. Okay, this is a node A and B. This is 4 Vx. If this potential is Vx, okay, this is your 10 ohm, this is your 5 ohm, this is 15 ohm. Okay, now to compute RTH, what you will do? We will connect a source here, a voltage source V, and we will assume that the source will provide current capital I. So this V upon I is nothing but RTH. Okay, so that we need to find out. Correct. So here, to solve this thing, so first I will assume that this current is suppose I1, right? And you can see that this potential is also V, because there is no resistance in this path. So current is flowing capital I, but there is no resistance here, so there is no drop. So this total voltage V will appear across this 15 ohm resistance. So this current, easily we can find out, this is V upon 15. Okay. Now, if I consider, so this total voltage, if I take KVL, can you take KVL here, this total loop? So this supply voltage V, same potential V. So that will be, okay, I am considering this one. The supply voltage is V, so minus plus is V. This is again minus plus, it is added, plus 4 Vx. Now what is the drop across this one? This drop across this one is 10 into I1. Am I correct? So this is plus, this is minus, so it is negative sign, minus 10 I1. And this is your Vx, this is plus, this is minus, so minus Vx, and that is equals to 0. Okay. This is one equation we can get just taking KVL in this loop. This is minus plus V, this is minus plus 4 Vx, this is plus minus 10 I1, this is your Vx, then this loop. So in this loop, if I take KVL, I will get this equation. Now we can see that if this current is I1, this current is also I1. So what is the Vx? Vx is nothing but 5 times I1. So I can write Vx is nothing but 5 times I1. Okay. So I need to use one equation that I am considering here. Okay. So if I simplify this thing, this is V, this is 4Vx minus Vx. This is 3Vx minus 10I1, and that is equals to 0. So Vx equals to 5I1, that I replace. So V plus, this is your 15I1 minus 10I1, and that is equals to 0. Okay, that implies V plus 5I1 equals to 0. Is it okay? Now what is I1? I need to find out V by I, that is RTH. So I1, you can see that this control, if I take KCL at this node, this current is coming I, incoming current, this outgoing current is I1, plus this outgoing current is V by 15. Am I correct? Are you convinced? Okay. So from here I can express the I1 as I minus V by 15. Good. So now what I can do, I can use these things. So this V plus, this is 5 times I minus V by 15, and that is equals to 0. So what is simplification? That I am writing here, okay? This thing I am writing here. Okay, I use different color. So this is your V, this is 5I, it is minus V upon 3, that is equals to 0. So if I combine these two, B minus V by 3 is 2B by 3, that is equals to minus 5I. So what is V upon I? Is minus 5 into 3 by 2. Yes, it is minus 15 by 2 minus 7.5 ohm. So RTH is, so VTH is 0 volt and RTH is minus 7.5 ohm. And please make a note here that RTH is now becoming minus 7.5 volt. It's a negative, and resistance can be negative if circuit is having some dependent source. But there is no guarantee that it is always negative. If it contains dependent source, it may be negative, but sometimes it is also positive. Okay? But negative, if we find equivalent resistance or Thevenin resistance is negative, obviously circuit should contain a dependent source. Otherwise, it cannot get a negative resistance. Okay? Now, is it fine? No. R can be negative. That is the thing I am discussing. If dependent source is there in a circuit, the resistance can be negative. So we can get negative resistance. Okay, so don't be confused. So if circuit is having some dependent source, the resistance can be negative. Don't be confused, it is possible, highly possible. But if circuit does not contain any dependent source, resistance cannot be negative. Now, yeah, if circuit is having only independent sources, no dependent sources, then Thevenin resistance is always positive. But if circuit contains some dependent sources along with independent sources, then Thevenin resistance could be negative, could be positive. But it could be negative. That's I am stressing, just I am giving you that in this example we have got it minus 7.5. But you can see that in our previous example it was positive. In this example it is negative, but in previous example it was positive. So you may get positive resistance or negative resistance, but negative resistance imply that circuit will contain some dependent sources surely. Okay. So can you solve this problem? Can you try? So this is a problem. We used to find out Thevenin voltage and Thevenin resistance for this network. So to solve this one, I'll use that method. Which method? I'll connect a source. Okay, I'll consider all the things at a time. I'll try to find out VTH, RTH simultaneously. Both the element I want to find out simultaneously using my method. And I have already discussed the method. What is this? If you have a network, okay, and if you connect a source V, and if you assume that the current supplied by the source is capital I, then try to find out a relation between V and I. You will be getting one linear relation. So this relation will be obviously V equals to I times RTH, and the independent term will be your VTH. So we will be getting both the parameters RTH and VTH simultaneously if we solve this network with this source capital V, voltage source. Okay, that I will try to do these things, and we will try to find out both the parameters simultaneously, not one by one. Okay, let us see these things. So what is the circuit? First I will draw the circuit. This is one current source, that is 1 ampere. This is the resistance, it is 20 ohm. This is the resistance, 20 ohm, and there is one dependent source. This is plus, this is minus. This 20 IV, where this current is IV. Okay. So what I will do, at this node A and B, I will connect a source. V, and I assume that this current is I. I need to find out a relation between V and I. A linear relation will be there, obviously. Okay. There could be something IV, but we should eliminate IV. Okay. Now this circuit is not very difficult, not very difficult at all. So you can see that this is the node, same node. Okay, and this node A to B, the potential is capital V. In this branch there is no resistance, so no potential drop. So this node potential is also V. Okay, there is no drop. So supply voltage is V, so this node potential is also V. With respect to this ground, if I consider this is ground and this is the node potential V, that is same thing, it is also V. Okay, now can I apply KCL? So this is same node, this is actually same node. Okay, at this node, this current is coming, incoming current I, some current is going through this side, this is the IV current, this is the 1 ampere current. So if you apply KCL, okay, Kirchhoff's current law, what you will get? This incoming current to the node is capital I, this incoming current is 1 ampere, both are positive. I am considering incoming current is positive, and outgoing current I will consider negative, it is a minus IV. Okay, and this current will be how much? V minus, this current is V minus 20 IV, because this potential is 20 IV, V minus 20 IV by 20, and that is equals to 0. This is the KCL. Are you convinced? Is it clear to all of you? Is it okay to all of you? Now what is IV? IV is also V upon 20. So you can see that what is IV? IV is simply V upon 20. So that implies 20 IV equals to capital V. Is it okay? So if you plug in there, now you can see that this 20 IV, this one is nothing but V. So what is happening? So you can see here that this is capital I minus 1 minus IV, and this is minus V minus V by 20. So this is going to be 0. So this is 0. What is the meaning? There is no current flow through this branch. The potential, how it is mentioned here, 20 IV and resistances, it is happening that there is no current flow through this branch. Okay, so what we are getting? This capital I equals to 1 plus IV. And what is IV? IV I can, so from here you can see that this IV, I can replace V upon 20. Okay, so if I use these things, so what I will get? This I equals to 1 plus V upon 20. Is it okay? So what is V? Can you simplify this V? V is 20I minus 20. I think I have made one sign mistake here. Is it right? This was positive plus sign. So this is negative sign. It is negative sign. Otherwise you will be getting negative voltage. Okay, that is not thing. Is minus. So this will become positive. Am I correct? So what is this equation? V equals to 20I plus 20. So you can see that this VTH, this is your RTH. RTH equals to 20 ohm, and this is your VTH. VTH equals to 20 volt. Right? So 20 volt and 20 ohm. So this is, we can find out both the things simultaneously. And if I ask you now, what is IV in this scenario? Anyone can find out what is IV in this scenario? When A B terminal is made open, remember, when A B terminal is made open, what is IV? Anyone can please tell me. Is correct, exactly correct, because open circuit condition, the VTH is nothing but VOC. So at A and B terminal, when it is open, the potential is 20 volt. That is the meaning of Thevenin voltage. So under open circuit condition, this potential is 20 volt. So if it is 20 volt, the current is, see, 20 by 20 is 1 ampere. Is absolutely correct. Okay, so we are running out of time. So this is circuit. Now I am leaving to you because time is more than 1 hour. So it is not on current and not on resistance, you need to find out. The same approach you can take. First you can find out VTH, RTH. So what you can do? So for this circuit you can find VTH and RTH if you are comfortable with Thevenin only. Then you convert it to the Norton current and Norton resistance. And this Rn will be same as RTH, and this I Norton will be simply VTH upon RTH. That is the simple source conversion. Okay, that is also you can do. Or Norton current, if you want to find out Norton current directly, you can find out ISC, short circuit current. A short circuit current ISC is same as I Norton. Okay, That also you can do. So you will try to solve these things. You can find out first VTH and RTH, and then you can find out this one, or otherwise directly you can find out short circuit current. That also it will be giving you this one. Okay. So anyway you can find out. So let me know if you have any issue. Because time is not there, we may discuss more problem later on. So if you can find out the solution IN and RN, please let me know in the comment section. You can share your answer in the comments. So is it useful? Is it fine to all of you? If you have any doubt, you can let me know. Otherwise, I'll close this thing here. We'll discuss more problem in another lecture. But if you can solve this problem, please share your answer in the comment section. So for this one, you can find out, I have given the hints that you can find out this open circuit voltage first, VTH and RTH, or as we did last time, we can connect a voltage source here, and then we can consider these things, the current I. Okay, the same thing, if you want to find out the same way, this is your current source, this is the resistance, this is the dependent source. Now here we will be connecting one source, okay. So this is your 3 ampere, this is your plus minus V0, 10 ohm, right? This is your 20 ohm, this is your 2 V0, correct? Now if I assume that this current is I and this voltage source is V, I need to find out a relation between V and I. So if this is I, what is the current through this side? So this current is I, 3 ampere, this side current is 3 ampere, this is I, so this current is nothing but I plus 3. Okay, and if this current is I, this current is also I, because again I will be getting the same current in this side. Because 3 ampere current is leaving here, again it is I. So voltage drop across this one is 20 into I, this is 2 V naught, and V naught you can relate 10 into, so but sign, you have to be careful about sign, minus sign, I plus 3 into 10. So first express V naught is minus I plus 3 times 10, then try to apply KVL. That's simple. You can find out V equals to the voltage drop. So this is minus plus, basically minus, you should consider it minus plus, so I can consider V plus V naught, it is a plus minus 20I, it is a plus minus 2 V naught, and that is equals to 0. Is it okay? So if you see that this one now, if you replace V naught by these things, you will be getting an V and I relations. So try to get V and I relation, and there you will find out VTH and RTH. So first find VTH, RTH, then convert it to I and RL. Okay, I hope you can do these things. Please solve this problem and let me know your answer in the comment section. Okay, so thank you very much for joining this one. I hope you have learned certain things, and if you have any problem, you can share this thing in the comment section. Okay, thank you.